All right. Here's what I want to do though, is because we've been on this a while, I want to try and finish this this section 1 up. And this is what I'm gonna do is I'm gonna kind of run through it and just talk as much as I feel I need to talk on each slide. I know this section is really boring, but I want to talk as much as I need to. I'm going to send you guys, I'm pretty sure I already sent it through live grades, but I'm also going through the PowerPoint here on our teams. And then I'm also going to take this video and upload it into our up onto my YouTube channel and send that link out through live grades as well. And I'm recording our teams, so either way it goes, you'll be able to see this and have it. Okay, even if you can't get on, if somebody can't get on to teams, they'll still have access to it. We'll finish this section 1 up so that I will see you guys and we can get started on section 2. Okay, we'll probably do that tomorrow and get section 2 knocked out of the way so that you know, we can start planning quizzes and stuff, because we need to get back into a normal, as much normal as possible. We already talked about minerals and their mineral characteristics. We talked about the Earth's crust being composed of about 3,000 different of these minerals, and every one of them are different. And the real big thing here in this section was where we hit it in class, and I really want to start pushing towards, is talking about those characteristics and how geologists use those characteristics, and we can use those characteristics to identify different minerals within just our environment. And knowing the rocks that are around us really means a lot. Knowing the soil composite and everything, especially if you like to plant a garden or something. If you're really good at it, then you can go as far as knowing what's in the soil, and you can add certain fertilizers to the soil to increase the nutrients for your crops to make them bigger. And in this, minerals are naturally occurring, they are inorganic, and they have a specific chemical composition. Like I said, they're naturally occurring, inorganic, and I don't need to talk a lot about that. And you have definite crystalline structure. And if you guys didn't get this before, like in class, what I talked about was when we were looking at crystalline structure, which is how some of these crystals form. You see in it, what'll happen is they will have a certain pattern, and this pattern will be formed in a geometric shape. And then what happens is it just keeps repeating that pattern, and it forms a crystal. Okay, like ones that you've probably seen girls' favorite thing out there. Whenever they look and they see a diamond, okay, this is a perfect example of that. Of what you'll see is that crystalline structure. It has a certain geometric shape, which gives the diamond its strength, and it just repeats the pattern to give us the diamonds that, you know, you'll go to the jewelry store and men are confused by the words that people at the store use, and girls just look and say, oh, it's so pretty and shiny, I love it. Then you got solids with specific compositions. In this, it makes a lot of sense. Okay, they have a specific composition, and they're made of certain elements. These elements form up in certain ways, and in some minerals, like feldspar, chemical composition can vary within a certain range. It depends on the temperature at which the mineral crystallizes. That makes a lot of sense. Different things will crystallize at different temperatures, so shouldn't be a big shock to you. And they are solids, so they have definite shapes and definite volumes that does not change, and each type has a chemical composition unique to that mineral. If at any point you have a question, please stop me and just ask. Within this, we talk about these rock forming minerals, and like you have these ones here, these rock forming minerals. I told you guys I didn't want you to write this table now because it's literally in your book. So you don't have to worry about that part of it. But 8 to approximately 10 of 30 most common of them are the ones that we refer to as our rock forming minerals. And that is because they make up most of the rocks in the Earth's crust. Okay, we're just talking the crust. We're not talking like the mantle and the cores. But in that, those are what we refer to as the rock forming minerals. And there's saying a lot to say there. So exciting, isn't it? This was pretty cool. It was talking about minerals from magma. This is like the one cool thing that I really enjoyed in my geology class is talking about the different volcanoes and talking about magma. And I told you guys before, magma and lava are the same thing, but it depends where you find it. So if it's underneath the Earth's surface, molten rock or molten material, it's literally molten rock, is magma. If it's on top of the Earth's surface and it's coming towards you and you're running for your life, that is called lava. So didn't want you guys to mix that up. If you ever seen lava coming at you and you were running for your life, I want to make sure that you communicated that when you called 911 and told them you saw lava, not magma. And that was an awful, awful joke. I know. I'm sorry. I'm trying to lighten the mood a little. Within this, though, magma is less dense. Since it's less dense, it will rise. Okay, so you know how density works with things separating out. This is the same thing. So it's kind of like oil on top of water. The magma is less dense, so it will rise, and it can break through the Earth's crust. And if it breaks through the Earth's crust, then it becomes lava. The type of number of elements in the magma determines which minerals will form. That makes a lot of sense. It depends what's in the ingredients to what you will get out of the ingredients. Okay, it's kind of like everybody's biscuit recipe. If you don't put a leveling agent in there, you're not going to get big fluffy biscuits. All right, if you don't, you're going to end up with hockey pucks. It's like cookies is a perfect example. I mean, you cannot put chocolate chips into your cookies and expect to get oatmeal raisin. Okay, if you want to get oatmeal raisin cookies, there has to be oatmeal and raisins in your cookies when you go to bake them. If you want chocolate chips cookies, you got to put some chocolate chips in there. I mean, it kind of just makes sense. It's the same thing here. Whatever's in that magma, when it cools and crystallizes, then that is what's going to determine what mineral you get out of it. And the rate at which the magma will cool, that will determine the size of the mineral crystals. Small crystals form from rapidly cooling or very quickly cooling magma, and the large crystals will form from slow cooling magma. It's like one cool thing that me and Mary has learned on the back of our house is where I have my grill at. We have like our back area where my grill is. It has a little bit of cover over, like it's a porch area. But at that, it comes off at an angle, and with all the snow and everything coming, whenever it melts and it slides down, it will make icicles on the back porch area. And they've been really big, and they've been really small. And if I have the big ones, it's because they're slowly cooling. So they will melt, the water will slide down, and it cools very slowly, which gives me the really long icicles. And if it cools, freezes really quickly, I get the small ones. Within this, we have minerals from solutions. So we have liquids that can be saturated, which means it's full of dissolved substances. And whenever we say it's saturated, it can dissolve no more of that substance. But there is a point to where there can be more pushed into it by different properties and things we can use from physical chemistry. And that is when you see a supersaturated solution. And in that case, minerals will actually crystallize into solids from those solutions. All right. And in this, minerals that form from the evaporation of the liquid in which they were dissolved are called evaporites. Just a big fancy name. And this is the big part where I want to start talking is geologists identifying minerals using tests based on minerals' physical and chemical properties. And the different things they look at are crystal form, luster, hardness, cleavage and fracture, streak, color, specific gravity, texture, density, and there are special properties for certain minerals. So let's start talking about these. And let's start talking about crystalline form first. So within this, some minerals form such distinct crystal shapes, they are immediately recognizable to geologists. However, perfect crystals are not always formed, so identifying based only on crystal form is very rare, which it is said and I'm not recommended to do. You need to piece these characteristics together. It's kind of like these characteristics are good fingerprints for these minerals. Somebody have a question? Okay, I thought I heard one of y'all unmute yourself. All right. In this, then we got luster, and you've heard me talk about luster before in the class where I said luster is a big fancy word for saying, oh, shiny. And there's two separate types of luster. So the first one is what you're most accustomed to. It's a metallic luster, and that's like a metal shiny, and a non-metallic luster, which is a non-metal shiny. All right. And this luster should usually be used in combination with other physical characteristics to identify a mineral. Like I said before on crystal form, we're going to use multiple of these characteristics to identify our minerals. We're not just going to use one of them. Then you have hardness. Hardness is a really big one, and it's one of the main things that geologists will jump to try and get an idea of what they're looking at, and one of the main characteristics they'll use. This is a measure how easily a mineral can be scratched, and we'll use different substances that we know their hardness to determine the hardness of that mineral. And the geologist that came up with this was Frederick Mohs, and he developed the scale, and we will still use this today to identify minerals. Now, the one that you're not going to find very helpful in the hardness test is a diamond, because that's the hardest substance on the planet. And we obviously, if you try to scratch something with a diamond, the diamond's going to scratch it. So, yeah. Ladies, please do not test this. If you think somebody has given you a fake diamond, do not go try and scratch stuff, because if you do, you're going to either find out that it's a fake diamond, or you're going to scratch stuff, and you know, your parents will not be very happy with you if you scratch something up. All right, so then we have cleavage and fracture, and I think this is where we left off actually in class. And the big difference is what cleavage and fracture is. So minerals will break, this is true, and they'll split, but cleavage has them splitting relatively easily. And the big thing with cleavage is it's a very even break along one or more planes of weak atomic bonds. So it's kind of like an even break, like it's very clean. It happens at distinct angles. These things happen in certain planes. While whenever you look at fractures is more of a break. It's rough, it's arc-like, jagged edges. It's not very clean. I don't know if you guys have seen this before or not, but the cleavage is a very clean break. You're like, oh, that's very neat. Fracture is not. Then we have streak, which is just focusing on the color of a mineral when it's broken up and powdered. And how we'll actually do this, there's a streak test, is we'll take the mineral and we'll rub the mineral against a porcelain plate. The very important thing to remember is if your mineral is harder than your porcelain plate, this is not going to work. You can't do this test because it will scratch the porcelain plate and will not give you any color whatsoever for you to identify the streak from what you're looking at. It's just not going to happen. We have color, and that's one of the most notable characteristics of a mineral. I mean, you just look at it and, oh, there's a color. Unless you're colorblind, you wouldn't use this characteristic. This is one of the most unreliable ones to use. Like, you really wouldn't want to depend on it. This is one of the last characteristics you really jump to find. Then you have special properties, and these special properties is like magnetism, iridescence, double refraction, effervescence with hydrochloric acid, and fluorescence. So the two big ones that are really cool, well, three really cool ones here that I like, is first is magnetism, and it's literally like it's a magnet, so I can like stick a magnet to it and it's attracted. The effervescence with hydrochloric acid, I really don't like the word effervescence there, but it's kind of like if you take Alka-Seltzer and put it in water and how it bubbles up and stuff. This is what it's talking about. So I take some hydrochloric acid and I just drop it on the rock and it bubbles up. So that's a really, really good indicator for us that we'll look at, and it'll give us a great idea of where we're going and what we're looking at. And then fluorescence is kind of like a glow stick. Like, you snap it, shake it, it'll glow, but you don't have to break this mineral. Like, it just glows, which is really, really cool. I never got to deal with any of those in physical geology, but it'd been real cool if I had got the opportunity to. So you look at text. Yeah.
It's time to switch classes.
Fantastic. Y'all can go right ahead. I'm going to keep going. If you got to leave, you leave.
Also, are we going to do an assignment in that packet you gave us today?
No.
Okay.
All right, so then you got texture, and texture is all about how something feels. You guys have heard this before, like you eat a certain food or something, you're like, ooh, I don't like it because of the texture of it. And it's the same thing here. Like, you can feel different minerals and see how the rocks feel. And this one's kind of like luster. It's very subjective. It is often used in combinations with a bunch of other tests. And if you guys haven't picked up yet, this is what you're looking at. You're looking at a bunch of these. All right, you're not just looking at just using one characteristic here. So then we have density and specific gravity in this, and two minerals of the same size may have different weights due to a difference in density. Density is mass per volume. That's the equation for that. And the density reflects the atomic mass and structure of a mineral. So this is a very helpful one to use. So like I was saying, density is mass over volume, and because density is not dependent on the size or shape of a mineral, it is a useful, very useful identification tool. And the most common measure of density used by geologists is specific gravity, the ratio of a mass of a substance to the mass of an equal volume of water at 4 degrees Celsius. This one's very helpful as well. And
any announcements that you would like our students to announce in the morning, or make that Thursday? Thank you.
And that's pretty much it, guys. So that ends section 1. Whenever you guys get back to school on Thursday, we'll actually talk about it. And besides that, if you guys have any questions, let me know. Okay? Besides that, you